So today we will be just discussing about the steel calculation, okay? And we will just do it from the basic to expert level, and we will just actually cover few things so you can apply them in a huge project. The first thing is actually how do we determine the weight of a steel bar? That's important, and many of the quantity surveyors they have just learned a formula which is just a plug and chug in, okay, and they don't know the about the basic concept, how these formulas come and where a formula should be used, okay. So it's important to know these things better. All right. And the first thing, let's just say if we have to determine the steel weight, okay. But before starting about the steel weight, it is important to learn about the weight because a weight formula can be like you can say if we take the volume of anything and then we multiply this with the unit weight of that material or maybe the mass. Okay, now don't be confused with unit weight and then mass. This is just quantity surveying. You can use both, okay, interchangeably, no problem. Okay, it's not physics. So the unit weight, okay, I'm writing weight over there. So the unit weight times the volume, this can be actually the weight of any material. Okay, I'm not talking about only steel. Let's say if we have some slab, okay, concrete slab like this one. And we have dimensions, let's say 6 inches is the thickness, the 10 by 10 is the size of the slab. And now, what should be actually, this is, let's say, RCC slab. What should be the weight of this RCC slab? Of course, you have to take its volume and then multiply it with the unit weight. It's very simple. So the volume can be actually 10 by 10 times 0.5. This is the volume. Okay, we have learned about these things before. Now, the unit weight, this is very important. What should be the unit weight of RCC work? What should be the unit weight of PCC work? What should be the unit weight of steel? So if you know all about all these things, okay, about the unit weight of each material, each engineering material or maybe construction material, then it's very easy for you. Okay, you have to just determine the volume and then multiply that with the weight. Very simple. Okay. Now the weight of RCC can be actually different. Okay, you have to check. There is a noise or maybe schedule about the unit weight of different construction material. You can just type the unit weight, okay, of different construction material in Google, and you can actually find that table over there. It will be just simple. Okay. So this time, the unit I'm gonna put the unit weight for RCC work is let's say 150 pounds. Okay. What do I mean by 150? 150 pound is actually 150 lbs per CFT. Okay. If you take 1 cubic feet of RCC slab, that can be 150 pounds. Okay. So 10 times 10 times 0.5, this is the volume, which is 50 times 150, that's actually 7,500 pounds. This is the weight of the slab. You can even convert this into kgs if you want. Because if you remember, 1 kg is just 2.204 pounds. Okay, so you can convert this by dividing it by 2.204. Okay, if you divide that, you can have actually the weight in kgs, and that's gonna be actually, if I'm not wrong, 3,402 kg. So this is the weight of the same slab. Very simple. Okay, and this is actually the basic concept. I'm just coming again into the steel work, no problem. Okay, if you have any shape, no problem. If you have slender, if you have cone, okay, if you have any shape, what you have to do is just to determine its volume, and then you can just multiply the volume with the unit weight. It's very simple, and that can be actually the weight of that material. So let's just have an example for steel. Let's say if we have a steel bar, Ehsan, आप इधर हो?
Yes, sir.
And let's say this is just the length of the steel bar, and let's take this is 5 meters. Okay, 5 meters is a huge value, no problem. And we will take the diameter is, let's say, 30 centimeters. Now, this is actually the diameter. It means the steel weight can be now very easy. We already know that the weight of the steel can be actually its volume times the unit weight. It means we have to determine the volume. Now remember, the volume of the same thing can be pi d squared divided by 4 because this is the cross-sectional area times the length. Okay, you remember that, Ihsan?
Yes, sir.
Now you
I
have
know,
to,
sir.
okay, that's good. Now you have to put values over here, like maybe for D is 30 centimeter or maybe 0.3 meter, okay, and divide by 4 times the length. What should be the length? That is 5, okay? It means the volume can be now, let me just do it very quickly. Now this is the volume, you can say 0.353 cubic meter. This is the volume, okay? Now we can put this volume over here in the same formula. W equals the volume, which is 0.353 times the unit weight. That's important. You know the unit weight, okay? Now it's also important that what type of steel is this? Is it cast iron? Is it wrought iron? Which type of steel is this? So the unit weight may be changed. However, in constructional projects, most of the time we use mild steels. Okay, maybe in slabs, in beams, in columns. Okay, so these are the mild steels normally. Now, the weight of mild steel bar is actually 7,850 kgs, if you remember this, per cubic meter. Okay, so you have to put that value over here. Now, again, you have to Google the unit weight of each material. So the process is just simple for you. Okay, just multiply the volume with 7,850. We have actually 2,774. This is actually in kg. Is it clear? Now, we will just move ahead for some formula stuff because calculating the volume and calculating then the weight, that take actually much time, okay? We will use some formula stuff, like maybe we have a formula for weight, which is d square by 162.198 times the length. Let's say if we have the same bar, so we can confirm if the weight is just the same or not. If we have 5 meters, and let's say this is 30 centimeter is the diameter. And let's say we are asked to work out its weight. So the weight can be now, we have to put, okay, important thing is actually the diameter can be in mm and the length should be in meters. This is important. You should know about this, okay? So we have 30 centimeter. It means the diameter is now 300 millimeters. So you have to take its square, okay, and then multiply this with the length, and the length should be in meters, so that's 5, it's okay. And then divide this by 162.198. Very simple. Now the weight can be actually, if you just calculate that using calculator or maybe any Excel maybe, okay, the weight can be 2,774 kg. It is the same weight, okay, is we did just maybe few seconds ago in the previous slide, okay? So it means the formula works. Very simple. Now this formula is actually for the MKS system. We have to look if for a formula which can also calculate the weight of steel bar, okay, if we have data in the FPS system. Okay, so let's just learn about that formula as well. We have a formula which is actually d square by 52.9, okay, times length. Over here, the diameter should be actually in sooth, and the length should be in feet. Very simple. Okay. Again, I'm just gonna take an example. Let's say if we have a bar whose length is 10 feet, and let's say the diameter that is 1 inch, then what should be its weight? Then the weight of the bar can be actually, we can put that video over here. As you can see, the diameter that is 1 inch. Okay. I told you that it should be in suits. Okay. 1 inch means 1/8 suits. Okay. So we're gonna put, it means, sorry, 1 inch is just equal to 8 suits. Okay, it's very simple. Okay, just remember it. 1 inch means 8 suits. 1 inch is further divided into 8 parts. It means suit is just the eighth part of the inch, okay? So we have to convert that into that part. Now, 1 inch means 8 suits, so we can put 8 for the inches. And remember, there is square for that, okay? And we will divide this by 52.9 times length. Length is 10 units, okay? Now, the weight should be actually at 64 times 10, which should be 640, and we will divide that by 52.9, which can be actually 12. So this is the weight of the same bar. This is actually the basic concept. Now, we will just move ahead and we'll have some practical example. Maybe we will calculate the steel bar for beam, the steel calculation for slab, okay, for footing, etc. Okay. So let's just do it. Now, which one element should I take from construction? Should be a slab or a beam or footing? Okay, it's your work. Tell me. I think for basic understanding, the slab is good. What do you say?
Yes, sir.
Okay, so let's just take a slab. Okay, and there can be actually structural drawing for that, but this time we don't have, so we will have just an example. Okay, let's say the slab is just 20 by 10 feet. Very simple. And let's say there are distributions bar. Okay, these bars are known by the distributions bar, which are actually in the longer span. Okay, or through the longer span, maybe you can say. The bars whose length is just more than the other directional, or maybe the bars which are above the main bars. Okay. Now let's say we are given that the main bars are let's say number 4, and they are 6 inches center to center. It means the distance between two bar that is just 6 inches. It's very clear and you guys must be familiar with that. Now let's say the distributions bar are number 4 and they are also at 6 inches center to center. Can be different, can be 12 inches, can be 9 inches, no problem. But this time this is just an example. Now let's say we have a section of the same slab, which is just in this form. Okay, and here are some bars, you can say just like that. I'm not going to represent that very clearly. Okay, the thing which I'm looking for is actually the thickness. Okay, and let's say the thickness of the slab is just 6 inches. Let me just connect my charger to my laptop because the battery is running out. Okay, just a second, I'm coming. Okay, are you guys there?
Yes, sir.
Okay, so this is actually the data we have. And let's say we have concrete cover. You guys know about the concrete cover, okay? It is just the cover of concrete, maybe from outer edge till the you can say the steel, and this is just the same distance. Okay, let's say we have the concrete cover over here, and over there is 1 inch, no problem. Okay, it can be different. Okay, in long project, we will actually cover these things in detail. This time we are just covering the basics, okay? So don't be confused about these terminologies. Now, the first thing is actually, if you remember, the weight of steel, if we need, is actually, we have to determine it by the formula, which is d square by 52.9 times L. Because we have FPS system over here in inches and feet, you can see that. So this formula can be used. Just we have discussed this, okay? Maybe a few minutes ago, if you remember this. You can also use D square, where is it? So you can use D square by 162.198 times L, okay? These two formulas are commonly used. You can use actually, of course, again, the volume times the unit weight to determine the steel weight, okay? So let's just have maybe something which I'm gonna keep these for the notes, okay? And I'm gonna have actually a duplicate for this so we can just determine the things, okay? Now, in order to determine the quantity, we actually need that formula, and for that formula, if you remember, we need the length of the bars. Over here, there are many bars, so the length of the bar can be actually something like complex, okay? That's why we have to determine the number of bars. And let's say, if I need to determine the number of bars, okay, and let's say I'm gonna say the number of main bars, okay? And the main bars can be actually, we will take the length, We will divide that by the center to center, and 1 bar can be added over there. Okay, is an extra bar. So this is the formula, you can say. It means the number of bars can be now the length. As you can see, if we need to determine the number of main bars, the main bars is actually just dividing the side, which is 20. Okay, it is just dividing the long space, it means. So the length will be actually taken as 20, and the center to center for the main bars, it is actually 6 inches or maybe 0.5 feet. Okay, and we will add 1 extra bar maybe for the start or maybe for the end. So the number of bars can be now 41 bars. It means these green bars along the span, which is 20, can be 41 in numbers. That's very clear. We are not subtracting the concrete cover because this is just wastage of time. We should not subtract the concrete cover over here. Because if you subtract the concrete cover, then the number of bars can be like 40 point something, okay? Which we actually directly then round it into 41. Very simple. Now, as we have the number of bars, we can actually calculate the length of the bars. Let's say the length of main bars. And that can be actually, if we say the total length, then the numbers, okay, and we will multiply the numbers with the length of 1 bar. Length of 1 bar. So this is the formula. Now, we have the number of bars, those are actually 41. And the length of 1 bar, we will determine that, okay, which is actually, if you see, the main bars are just 10, okay, in length. However, we can now subtract the concrete cover for one side and another side. You can say 10 feet, and we will subtract concrete cover for one side and another side, or you can say 2 times concrete cover. And the concrete cover, that is 1 inch, and you can actually divide that by 12 to convert that into feet. What do you say? Very simple, okay? So this is going to be the length of 1 bar. Now, 1 over 12 times 2, that is the concrete cover, which is 0.16 something, okay? And we will actually subtract that from 10. It means the length of 1 bar, or you can say the cut length, can be 9.833. So this is the thing you have to actually tell the steel fixer, okay? Steel fixer have to cut the bar, okay, at the same length, which is 9.833. Now the total length can be actually the total length, I will say T length for the main bars, okay, can be actually 9.833, which is length of 1 bar. And we will actually multiply this with the number of bar, which is 41, okay? Very simple. So 9.833 times 41, that can be, if I'm not wrong, it can be 403.167 feet. Very simple. Now we have to put this in the same formula, like maybe the weight can be now d square, okay? This time the bar diameter is just, that is number 4 bar, it means 4 suit, okay? And there is square over there, and divide by 52.9 times the length, which is 403.67 feet. It means the quantity can be now 4 fours are, that is 16, and times the length, and then we will divide that by 52.9. So the quantity can be in kgs, and that is 121.94 kgs. Very simple. Okay. This is
सर
how we,
मेरा एक क्वेश्चन है सर क्वेश्चन है एक
yes,
सर ये डी में हम नंबर ऑफ बार पुट करते हैं ना
yes, yes, exactly.
वो नंबर जी सर यही बात कर रहा हूँ मैं तो यहाँ पर हम इंचेस में क्यों नहीं पुट करते सर अगर हम देखें तो सिस्टम सारा फीट में चल रहा है तो यहाँ पर तो होना चाहिए था सर
This is very good question. वेरी वेरी गुड क्वेश्चन। मुझे भी ये पसंद नहीं है कि भाई बंदा इसको फिर सूत वगैरह मिले। तो इसके लिए आंसर मैं आप लोगों को यू बताऊँ ना, कि जब आप इस फार्मूले को डिराइव करते हो डी स्क्वायर बाई 52.9, यहाँ पे एक और फार्मूला भी है डी स्क्वायर बाई 162 पॉइंट समथिंग, ओके। another formula we have is actually d square by if I don't forget that 24, that one is, okay. So we have different formulas over here. Now, while deriving these formulas, the deriver, you can say, they have just converted the diameter into that suitors or maybe mm. Okay, I will also teach how to derive that formula, and then you will understand why we take diameter in mm or maybe in suit. Okay, so after derivation, you will understand that. However, it is not necessary, it is not important that you should use the same formula. It is never necessary. Okay, you can use your own formula. Just derive another formula. Okay, I will show you how to derive by yourself. Don't worry about that. Just derive another formula for yourself where you can put the diameter in inches. What do you say?
ठीक है सर.
So it was just for the main bar. So we have, you can say, we will say 122 kg. Okay. So the main bars, which are actually number four bars can be, we should buy 122 kgs for the same slab. Now let's just talk about the distributions bar, which are known by the temperature bars also. And we will just calculate the number of bars. For that, we will take the length, which is actually 10 feet. Because as you can see, the distributions bar, they are just actually dividing the same length, which is 10 feet. Okay, so 10 by the center to center distance, that is 6 inches. And we will add one bar extra. So this is now actually, you have to just divide 6 inches by 12 to convert that into feet. Okay, this is going to be 21 bars. Now, length of one bar can be actually, let's say, length of one bar. Length of one bar should be actually, as you can see, this is 20 in length. Okay. So we have to subtract 2 inches for one side and another side is concrete cover. So we have 20 minus 2 times concrete cover or 2 times 1 inches. Very simple. Okay. So 1 over 12, that is actually something like 0.08 and multiply that with 2. Now you have to subtract 20 minus the same answer. And that's actually length of one bar, which is 19.833. Now the weight is very simple. The weight can be actually d square by 52.9 times L. Now diameter again, over here we have number 4 bar. Okay, so 4 that is actually 16 or maybe 4 square divided by 52.9 times length. Length is also known. Okay, now important thing, which let me just erase this. Okay. We actually need the total length, not length of one bar. So the total length, which means the length for 21 bars can be actually, let's say, 21 times length of one bar. What do you say? This is what we want, and this is necessary. Okay, so we have 21 bars times the length, which is actually going to be 416.5 feet. It means we have number 4 bars and whose length is actually 416.5 feet. Now we will actually calculate its weight, like you can say W equals D square by 52.9 times L. Okay, so D, that is 4 and square 52.9 times L is actually 416.5. Okay, now the weight can be actually 4 4s are, that is 16 times 416.5. That can be 6,664 and divide that by 52.9. We can have actually the weight in kg 125.9. You can say 126 kg. Very simple. It means that number 4 bar, we actually have to buy, you can say, for the same slab is the same thing is 126 plus the main bar's quantity. If you remember, what was the main bar quantity? And it was, if I'm not wrong, 121. Okay. Was it 121 or 122? It was 122, yes, plus 122. So we have to buy the main bars, like maybe 126 plus 122, and that should be 248 kgs. So this is the requirement for the same slab. Is there any question?
No, sir.
It is just straightforward, and you guys have already practiced this, I think.
सर आज बंद है बहुत कम है. पता नहीं सो रहे हैं या क्या वजह.
आज हमने स्केड्यूल चेंज कर दिया ना, तो 10 बजे पे अक्सर लोग सोते, रमज़ान है ना, और आज तो संडे है, इसलिए हमने सुबह के टाइम पे रखा हुआ है क्लास।
मैं तो कहता हूँ कि एंड कर दे सर, बंदे भी नहीं है तो इससे फिर काम हो जाएगा।
हाँ ठीक है फिर।
यस सर।
ठीक है, ओके, अल्लाह हाफिज, अपना ख्याल रखिएगा।
ओके सर। ओके सर, थैंक यू सर।